Hey Algebra 1, here are your notes for 12.9 Solving Rational Equations Day 2. I'm super glad you had so much fun yesterday that you're back for even more. So, let's jump into it. All of this is the same from yesterday. We're still talking about extraneous solutions. Notice I say part 2 involves solving with a more challenging mix of denominators. You knew it was going to get harder. Well, let's go. I'm not going to read all this because it's basically what I said yesterday, and I think the easiest way is to just jump on in. So, you'll remember yesterday I talked about multiplying through with that LCD, and I said it was really easy if it was two numbers like 2 and 3, because, obviously we can multiply everything by 6. Well, today we're going to work with something a little more challenging, but the only difference is that challenge comes in the form of variables and expressions of variables in the denominator. But the method stays the same. This time, instead of finding the LCD of numbers, I'm going to find the LCD of variables and expressions. So, let's jump in. How do I do this real quick? All right, it does say state extraneous solutions first and then solve. I made that mistake in yesterday's video. So, let's do that first. The first value that n cannot be, because it would cause a problem, is 0. We cannot divide by 0. That takes care of the first fraction and the third fraction. When we check the second one, we notice our second extraneous solution is 6. Now I'm going to multiply through just like I did the other day. But instead of multiplying through by one number, I have to multiply through by something different. Notice the LCD in this case is the n and the n minus 6. So when I multiply through to knock out those denominators, I'm going to multiply by the LCD instead of the lowest common multiple like I did yesterday. So when we do this, notice when I multiply this in to my first term, the n is going to cancel because I have n over n. So the first term is going to be n minus 6 times n minus 2 because those n's cancel out. In fact, I'll show that for this, only for the first example though. All right, minus, when I multiply it in, those cancel, so those are gone. The second term, again, I have n times n minus 6 times n minus 3 all over n minus 6. By multiplying by the LCD there, the n minus 6 is going to cancel. And then in the last one, I have 1 times n minus 6 over n, meaning that n cancels. So now you can see that by multiplying by the LCD all the way through, it allowed us to knock out a denominator, just like I showed up here. Now we have to figure out what's left over. We've got n minus 6 times n minus 2. Might as well simplify that as I go through, so I'm going to FOIL that to be n squared minus 8n plus 12 over 1, so I don't have to write that, minus n times n plus 3. Notice that negative has to be distributed to everything. The fast way of doing that is just multiplying negative n by n and negative 3. So it'd be negative n squared and positive 3n, because negative n times negative 3 is positive 3n. And there's nothing else in that term. And then, of course, 1 times n minus 6 is just n minus 6. Now, I know that that looks like a lot, but here's the thing. We're going to simplify it the same way we always do. N squared and n squared are like terms, but 1 minus 1 cancels those out. I have negative 8n plus 3n. That's negative 5n. I have a positive 12 on the left side, and then on the right side, I still just have n minus 6. Notice just by simplifying down on the left side, we've made this problem a lot more manageable. Let's keep going. I'm going to move the 5n to this side by adding it over. So I get 6n. I'm going to add 6 over here. So I get 18. Solve it by dividing by 6. My answer is n equals 3. And then just to be thorough, I'm going to bring down those extraneous solutions so that they're right next to my answer and they're easy to see. Oof, that was a lot. That's okay. We're going to see it again. Let's check for those extraneous solutions. What values can A not be without causing issues? Quick one, -1. When we solve for A plus 1 equals 0, we get -1. And then again, we just have a plain A, which means if we plug a 0 in for A, we're going to have some issues. All right, now let's get to solving. Just like I did with the last one, I'm going to multiply by the LCD. In this case, that is taking A and A plus 1. I can't just take an A and then take a plus 1 because this, remember, is grouped in parentheses. So I have to take the entire thing. Now, unlike this problem where I showed you where they cancel, I'm not going to do that this time. Notice in the first one, they cancel out. So all I have to multiply is what doesn't cancel, meaning -4 in A. In the second term, the A's cancel, so all I multiply is the 3 in the A plus 1. So plus 3A plus 3. I got the plus from right there. Equals 1. Notice nothing cancels out on the bottom, so I have to do 1 times both of those. A squared plus A. I just simplified it in the process. Now that we've got a one-liner, let's simplify. -4A plus 3A is -A plus 3 equals A squared plus A. I can already tell that I've got a trinomial in the works here because this A squared isn't going to cancel. So I'm going to move everything over to that side. So I have A squared. When I move this A over, I add it, plus 2A minus 3. And then all I get on the left side is a 0, so I'm going to move that to the right side. All I've done is simplify this step. All right, now in order to solve for A, we have to factor. A, 3, 1. In order to get a positive 2 in the middle, I've got to do a positive 3 and a -1. Remember, our zero product property says that we set this equal to 0, we set this equal to 0, and our final answers are A equals 1 and A equals -3. Let's circle those again for the sake of thoroughness. I bring down those two extraneous solutions, and there's my final answer. All right. There are 4 more on the back. I want you to go ahead and pause the video. See if you can do these on your own by multiplying through using that LCD. Once you've given them a shot, come on back. We'll try them together. All right, hopefully you had enough time to try those on your own. I do know it's a little bit hard to see my screen, but I'm going to do my best here. All right, example number 3. This one only has x minus 1 in the bottom, but since our LCD only takes one of those, I technically only have to multiply by x minus 1. I don't have to do it twice because if I do it once, it cancels off. It cancels off in the first one. It cancels off in the second one. Oop, this is supposed to be a minus. The only one it doesn't cancel in is the last one, so we're going to multiply 6 by distributing it in and making it 6x minus 6. Fabulous. Let's simplify it down. 3x plus 6x is 9x minus 9 equals 6x minus 6. I like the balance of this problem. It's not relevant to solving it, but I like the balance. I'm going to move the 6 over, 3x on that side. I'm going to move the 9 over, positive 3 on that side, x equals 1. Now I know I didn't start by solving for the extraneous solutions. I always think of that at the end because I always remind myself, does this actually work in the problem? Sadly, when I go back to check and I look for my extraneous solution, I find that the only value that won't work is 1. So when my solution is 1 and my extraneous solution is 1, no solution at all. Doesn't work. Next one, I've got negative n, 1 minus n here. I've got n squared minus 1 here. I'm going to make this problem a little bit easier on myself right away by rewriting this problem. We talked in a previous video about rewriting this, excuse me, by moving the negative up to the top and making it negative 2n, I can turn it into n minus 1. Why does that help me? Well, it helps me because when I look at my second term, I notice that the denominator is a difference of squares, which can be factored to n minus 1, n plus 1. Once I see that, I should notice that the only LCD I now have to multiply by is n minus 1 times n plus 1. If I hadn't done this, I might have also multiplied by 1 minus n, and then I'd have a lot going on here. So just by rewriting it and simplifying it, I've saved myself some work. All right, now we're going to multiply by n minus 1, n plus 1. In the first one, the n minus 1 cancels, so I have negative 2n times n plus 1. That becomes negative 2n squared minus 2n. Plus, when I multiply this into my second, both of them cancel, so I'm just left with the numerator. And then equals 1, since neither of them cancel, I'm left with n minus 1 times n plus 1, which I know when I simplify it becomes n squared minus 1. All right, now that I've knocked out those denominators, let's jump into simplifying. I like to simplify the left side first if I can. Negative 2n squared minus n plus 3, n squared minus 1. I'm going to, let's think of an easier way to do this. Let's actually move the 2n squared over so I don't have to work with a negative leading term. Since I'm moving everything over there, might as well keep moving. Let's move the n over, and then let's move the 3 over. So plus n minus 3. So once I've done all this, I get 3n squared plus n, negative 1 and negative 3 is negative 4, and it all equals 0. Oof, that is a lot. I do see that I have a trinomial, so I'm going to go to the idea that I have to factor it. The only thing to do with a number out in front is that X puzzle. I'm going to let you do that now, if you haven't already. And then I am going to do it in my head because that is how I learned it. And I don't always use the X puzzle if I think I can figure it out. I like to challenge myself. 2 and 2 would give me 6 and 2. That wouldn't work. 4 and 1 would give me 4 and 3. So let's do 4 here and 1 there. In order to get a positive in the middle, this is going to have to be positive 4, negative 1. 3n squared, negative 3n, positive 4n, negative 4. Perfect. Equals 0. Set them both equal to 0 using our zero product property, and find that n is either going to be negative 4/3 or positive 1. Those are our two solutions. Let's go back and check for any extraneous in our original denominators. When I do that, I find that the values that n cannot be are 1 and negative 1, one of which is in my solution. So I'm just going to go ahead and cross that out and say that doesn't work for me. Underline, I'm good to go. All right, keep going here with example 5. Again, I want to simplify this, actually all of the denominators, to see if I can make them look a little bit nicer. I get 7, I see a GCF, so I'm going to factor out an x. I'm left with x minus 5. Notice 5 minus x and x minus 5 are not the same thing, as we have previously discussed. So I'm going to move that negative up to the top. I'm going to make this positive into a negative so that I can write it as x minus 5. I don't have to simplify anything with the 4x, but now that I have 3 fractions to look at, I have to make sure I have the LCD of all 3 terms and not just the first 2. So the LCD, I only have one instance of an x. It's the highest number of times that shows up. And then I have x minus 5, but that only shows up one time, so I only have to take it once. And now we do the same thing. In the first one, everything cancels out. We're happy. In the second one, only the x minus 5 cancels out, so I have to do negative 3 times x. And in the third term, only the x cancels out, so I have 4 times x minus 5. So 4x minus 20. And now we simplify. I'm going to move that 3x over here, move the 20 over there. Oof. Yeah, that one doesn't turn out nicely, which is unfortunate. X equals 27 over 7. Not a super nice answer, but we're okay with it. And then let's just double check to make sure there's no extraneous solutions. Ooh, there we go. In my first one, it can't be 0, and it can't be positive 5. In my second one, it can't be positive 5, and in my last one, it can't be 0. So that sums it up. All right, makes me sad, but we are on that last one. Let's rock it together. Same thing, let's simplify 3t over 3 outside of t minus 1 minus 1 over, when I take a 3, I get 3t plus 1. And in the last one, I just have a single one. All right, my LCD in this case is going to be 3, because I see it shows up in both. And then, unfortunately, both of these are going to be in my LCD because they only show up one time, but they do both show up. So 3t plus 1. All right, let's do it. In the first one, the first 2 cancel out, so I have 3t times 3t plus 1. That gets me 9t squared plus 3t minus the 3 and the 3t plus 1 cancel out, so I'm just left with 1 times t minus 1. Notice I put it in parentheses to remind myself that that negative has to be distributed in, equals, since this is only a 1, nothing cancels, and I have to bring everything along for the ride. Not bad right now, but sometimes simplification can be a little tricky. All right, let's simplify. 9t squared. When I distribute this in, I get negative t, so 3t minus t is going to be plus 2t. Negative times negative 1 is positive 1. And it equals, just to make this easier, I'm going to make this into 3t minus 3, and then I'm going to FOIL it with this one. 3t times 3t is 9t squared. 3t times 1 is positive 3t. Negative 3 times 3t is negative 9t. And negative 3 times positive 1 is negative 3. All right, let's simplify. I'm going to subtract this over. It does cancel, which is kind of nice. And I'm left with 2t plus 1 equals negative 6t minus 3. All right, move the 6 over, I get 8t over here. Move that 1 to this side, I get negative 4. Simplify that last step, and I get t equals negative 1/2. And then, of course, we finish the problem the same way. Let's check for any... Ooh, it's hard to get both of those on screen. That works. In this first one, if I need to check 3t minus 3 equals 0, that's 1. one of my extraneous solutions. And my second one is when I do 9t plus 3 equals 0. My second extraneous solution is negative 1/3. Neither of those cause any problems with the solution I found, so I leave it circled, leave those underlined, and I am good to go. That is the end of chapter 9. I know rational expressions can be kind of tricky sometimes. They can throw us a few curveballs, but have no fear as we have conquered them together. I'm super proud of all your hard work in this chapter. Let me know if you have any questions.